Hello everybody, this is Mr. Longo, and in this video we are going to cover graphing rational functions. At this point, you should have already watched the video on simplifying rational expressions. If you have not, make sure you go watch that video first. It will make this a little bit easier to understand. Okay? So, graphing rational functions. This first part of the video, I'm just going to spend a lot of time talking about what I've written out for you because it's just here to help you. And then once we do some examples, it should be a little bit easier to understand. But a rational function, as you know, is pretty much an expression that has a function, both the numerator and the denominator, and are polynomials. So to talk about the different aspects of these graphs, you are going to have things such as vertical asymptotes, horizontal asymptotes, and holes. So a vertical asymptote is a line on a graph that a graph can approach, but it'll never touch. Okay, so to give you an idea, you're going to represent your vertical asymptotes as dashed lines. And basically what an asymptote is, it's a part of a graph that it will never actually touch. Okay, so it'll approach it, but it won't ever touch it. Okay, so that's for a vertical asymptote. And how do you find the vertical asymptote? Well, the first thing you have to do is simplify both your numerator and denominator, and simplify the entire function. And after that, you just set your denominator equal to 0 and solve, and that will tell you what your vertical asymptote is going to be. Now, similar to a vertical asymptote is a horizontal asymptote, which represents a line that a graph is not going to reach, but special note, it's only on end behavior. So when we have multiple parts to a function, horizontal asymptotes only apply to the end behavior. It can actually cross in the middle. So if we had a function that looked a little similar to that, the end behavior will only approach that horizontal asymptote. It could actually cross it in the middle, just so you know. Now, the horizontal asymptote is a little bit trickier to decide what it's going to be, so I have a little chart here for you. First things again, you have to simplify it. Now, after you simplify, we have to look at the degree of the numerator and the denominator. And if the degree in the numerator is higher, then we're not going to have a horizontal asymptote. If the degree in the denominator is higher, then we're going to have a horizontal asymptote at y equals 0. If the degrees are the same, then we're going to use the fraction or the leading coefficients. And sometimes it'll just be 1 over 1. Other times it could be 2 over 1. Sometimes it'll be 1 over 2. But if that's only when the degrees are the same. Now, if you're wondering where my m is greater than n, or m is less than n, or m is equal to n, that goes back to this generic equation of a function that I have. Now, obviously, it just means the numerator versus the denominator. And if they're the same, it's the fraction of your leading coefficients. Okay? And then finally, a hole is just a single point on a graph that is undefined because terms cancel. So to do that, what we're going to do is we're going to simplify, and then we're going to set what we cancel equal to 0 and solve for x. And then once we have our x value, we're going to substitute that into the simplified equation, and we're going to find our value of y. Now, I just talked a lot, but it's much easier to understand once you see it. But the reason I wanted that all written out for you is so you can print it out and use that as step-by-step instructions for doing so. So let's go and talk about a few different examples. Now, I just want to let you know they're all factored out for you. I didn't want to spend time factoring here. We should know how to do that, and we should know how to simplify. So the first example here, we can see what we would cancel is x minus 2. And if we were to set that equal to 0, we know we are about to get x equals 2. So that's going to be our whole part. What we cancel is set equal to 0, and we solve, and we get x equals 2. But we also have to write this in its simplified form. So we would be left with x plus 2 over 2 times x minus 1. Now, to find our whole after we get 2, we have to substitute that back into this simplified equation. And that would give us 2 plus 2 is 4 over 2 times 2 minus 1. So 2 minus 1 is 1 times 2 is 2. That would simplify to 2. So we're going to have a whole at 2 comma 2. Our vertical asymptote. Our vertical asymptote happens when we set the denominator equal to 0. So if we were to set 2 times x minus 1 equal to 0, we would divide both sides by 2, and that would still give us 0. We would add 1, and we are going to have a vertical asymptote at x equals 1. Notice I have the x equals because it has to represent a vertical line. Now, the last part is our horizontal asymptote. So this is where we look at the chart, and we have to determine that the degrees of the numerator and denominator are the same. So we have first degree. If we were to go back to the beginning, if we were to multiply those out, we would have x squared and x squared. They would both be second degree. So since the degrees are the same, we use the ratio of our leading coefficients. In this case, we can see that it's 1 over 2. So our horizontal asymptote is going to be y equals 1/2. Okay, so that's how you approach these. If you would like to pause the video and try the next two on your own, go right ahead. Otherwise, I'm just going to go through them with you. So pause it if you'd like. Otherwise, here we go. This second example, we see that nothing cancels out. So if nothing cancels out, we just say that we have no hole, or none, or don't have one, leave it blank, whatever. So there's nothing we can do there. The vertical asymptote, that's when we set our denominator equal to 0. So if we set both parts, we have x plus 1 equal to 0 and x minus 2 equal to 0. We have two vertical asymptotes. We have a vertical asymptote at x equals a -1 and another one at x equals 2. Remember, they each get an x equals because we are writing equations of vertical lines. Finally, we're going to express our horizontal asymptote. Now, horizontal asymptote, as you remember from the chart, and if not, that's why I wrote it all out for you. You can look at it. If the denominator is higher, it's y equals 0. That's how you use that chart. So we have second degree in the denominator, but only first degree in the numerator. So we have y is equal to 0. Okay? That's how it's done. Last example we'll just talk about really quick as well. We have a whole because those cancel. So that's going to give us an x value at a -2 comma. And then we just need to substitute that back into our simplified equation. Our simplified equation is x squared over 3. So a -2 squared is 4 divided by 3 is 4/3. So we have 4/3 for the y coordinate of our whole. Our horizontal asymptote. Horizontal asymptote, there's a higher degree in the numerator, so we just have none. We do not have a horizontal asymptote. And finally, our vertical asymptote is also none, because we only look when we're simplified. We cannot set 3 equal to 0. Okay, so this is just going to look like a quadratic with a hole on it, and that's it. Okay? So now we've talked about the parts. Now we need to talk about putting this all together and actually graphing it. Now, special note, I am not going to make you graph these by hand. I expect you to know how to plot your vertical, horizontal asymptote and your holes, but as far as actually graphing it, we're going to rely on our graphing calculator to help us out with that. So at this point, if you would like, go get your graphing calculator and let's get ready to use it. Alright, so I have my graphing calculator up here for you to help you along. But this is what we're going to do here. We are going to first simplify. So the first thing we're going to have to do is factor our numerator and denominator. So the numerator would be first factor out a -3, leaving us with x squared minus 1, which we could factor to -3 times x plus 1 and x minus 1. Over our denominator, we can just factor to x minus 2 and x minus 1. And we can see that we have cancellation here, meaning 1 comma something is going to represent our whole. And then our simplified equation is going to be -3 times x plus 1 all over x minus 2. Okay, so we simplified our function. And we need to discuss some more parts. Now again, the vertical asymptote we should be able to do in our head. X minus 2 gets set equal to 0. So we're going to have a vertical asymptote at x equals 2. Now this part you can graph without the use of a calculator. We're just going to graph a vertical line. Notice it's dashed at x equals 2. Our horizontal asymptote. The horizontal asymptote is based on what do we have in our numerator and denominator. Well, we have the same degree. So that means it is going to be y equals a negative 3. Remember, if the degrees are the same, it is the ratio of the leading coefficients. So we have a negative 3 over 1. So we have a y equals negative 3, and we are going to go over here and just kind of sketch our horizontal line. Dashed, of course. Remember, solid lines represent something that's for real. Dashed lines are not there, just kind of there as guides. Now, to finish up the whole. The whole, we just need to substitute 1 back into the equation. So 3 times 1 plus 1 would give us a negative 6 over 1 minus 2, which would be a negative 1. That would reduce to 1 comma 6. So if we go to 1 comma 6, we can sketch the whole. And now, this is the part where you need to use your graphing calculator. And then we will talk about our domain and range. So there are ways with the calculator that you can create a fraction bar and type the numerator, but there are some people that are still using older calculators. So I'm going to type it in. That will work for all people. And that is to type your numerator in parentheses, then divide it by and put your denominator in parentheses. Now you might be wondering, why am I using the original instead of the simplified version? Well, I'm actually going to put both in, and I'm going to tell you why in just a second. So in Y1, I'm going to do that. Now, you only have to do one or the other. Now, if you type the original in, it will give you the correct graph, even if you accidentally simplified. So that's why I'm going to do both of them, just to kind of help you along. So over here, I'm going to do a negative 3, parentheses again, x plus 1, close parentheses for the x plus 1, close it for the numerator, divided by, now your denominator also goes in parentheses, so x minus 2. Now the reason I did that is because if we were to graph, I'm just going to press zoom 6 to make sure we have the right window, we should see the graph appear twice. That will tell you if you simplified it correctly. If you made a mistake and accidentally simplified one of your parts wrong, what if in Y2, for some reason or another, when you factored it, you have an x minus 1? If you click graph, you will have two different graphs, which would be a red flag warning to you that you did it wrong. That's why I type them both in, just so you can see that little trick. Okay? So here we go. So this is what we're looking at here. Now, to graph that, all you really need to do is press second table and get some good points. How am I at 400? I want to remind you that you can go to your window and set your table start to 1. So we go look at the table and just go plot some points. While you're plotting these pretty points, I also want you to take special note of the errors we have. So remember, a vertical asymptote is not going to allow anything to work when we're at x is equal to 2. So notice it appears twice. But notice for our whole at x equals 1, it's an error in our non-simplified equation, but it is 6 in our simplified equation. That's because this is our original equation, so they cancels and creates just a whole at that one point. And that whole is going to be from our simplified equation 6. Now, again, you would just take some points, so you would go plot maybe 4 comma negative 7.5, and you would come up with a bunch of them that are going to fit. I know that 3 is at a negative 12, but basically you're just going to create some good points and sketch the graph. Now, the other reason why you should use your graphing calculator is we should see a whole bunch of the points that we've already created, such as the hole. If your hole is not touching your graph, you've done something wrong. So that's another thing you can do to check. Okay, so now let's talk about domain and range. Domain is x cannot equal any x coordinates of our hole, like we talked about in the previous video, but it also cannot equal the vertical asymptote either. Remember, that pops up as an error. So that's your domain. X can be anything except for those two. Now, your range sometimes follows this rule, and the rule is y can be anything except y is not allowed to equal the y coordinate of our hole and our horizontal asymptote. Now, for that situation right here, it works, but it does not work in all situations. So before you write your range for a graph, you should always check to see what the graph looks like. Now, in number 5, our last example for this video, you're going to have a funky looking graph, and the range is not going to follow the rule. So what I want you to do here is I want you to plot or answer as much of this question as you can. I want you to type it in your graphing calculator and list out what you can, and I'm going to just talk about everything and kind of show you what you should have gotten, and after that we are done. So pause this video and give this last one a try. So again, we have to first look at what's canceling, and we have our x minus 2 and our x minus 4s. So we're actually going to have two holes then. We're going to have one at 2 comma something, and we're going to have one at 4 comma something. Now, we should simplify this equation, which we are going to get 3x plus 1 times x plus 3, and that's going to be over x plus 1 and x plus 5. Now, after we were to substitute those back in, what we should get for our holes is 2 comma 5/3 and 4 comma 91 over 45. Now, of course, you might type those in and get the decimal values of 1.667 and 2.022 because that would help you graph it, okay? So definitely type those in to see where you should be graphing it. Now, we have two vertical asymptotes here. We have one at x equals a negative 1 from the x plus 1, and we have another one at x equals a negative 5. So again, you should not need your graphing calculator to do that part for you. So we have an x equals negative 5, and we have an x equals negative 1. Those are going to be our vertical asymptotes. The next thing we're going to need to do is our horizontal asymptote. For our horizontal asymptote, we should have one at y equals 3, because if we were to take our leading coefficients, we have second degree on top, second degree on the bottom, so we have 3 over 1, and that's going to give us a y equals 3. Now, I'm going to save the time of typing all that into our graphing calculator because we should be able to do that, and this is what's going to happen for the graph. We are going to have a branch of the graph over here. We are going to have another branch of the graph over here, but I'm first going to plot my holes. So we have one at 2 comma 1 and 2/3, so that's approximately right here. And we have another one at 4 comma 2.02, so that's practically right here. And for sketching that part, remember, after you go look at all the pretty points on your graph should follow through those and make sure that you are hitting both of those holes. Now, the weird part is in the middle. If you type that in your graphing calculator, you notice that you had something go all the way through, and that's where this whole thing of the range pops in. So our domain is always going to follow the rule. So the rule is, again, x can be anything except for x cannot equal any x coordinates of holes 2, and 4, or any vertical asymptotes, -1 and -5. But our range in this case is y can be all real numbers. Now the reason why is the graph starts and ends in this middle section going all the way to top to bottom. So it crosses the horizontal asymptote. Even though there's no y value here at 5/3, it's taken care of here on the line that passes through. So that's why I was saying you always have to check your graph. Okay, so that's it. I just wanted to make sure we covered how you have to look at the graph for the range. I know it's a long video, but there was a lot to cover. But anyway, this is Longo, and I'm out. See you, bye.